So for this video, I've actually decided to look into the Friedel-Crafts alkylation and acylation to a little more depth because you have to be very, very careful with Friedel-Crafts. Okay, this is where we were able to do and substitute a hydrogen on benzene with either an alkyl group or an acyl group. So let's just do a quick review. With Friedel-Crafts alkylation, remember the part of it was you had this alkyl halide, and you're wanting to actually add the R group to the benzene ring because it's delta plus, the X is delta minus, and you use this Friedel-Crafts catalyst called aluminum trichloride. And what happens here is the X actually gets coordinated briefly, transiently, to the catalyst, and so it looks and behaves like this. Let me change my color. Okay, so it really is looking and behaving more like this species down here, and so that's the reason why the benzene ring can come and attack the R. But now let's think about the characteristics of a carbocation. The problem, or one potential problem, is let's say, for example, that, and I'm just going to use butane. Technically, this would be, 1-chlorobutane, and whenever we put this in the presence of AlCl3, low temperatures, it's going to look and behave like this. 1, 2, 3, 4. That's a carbocation, AlCl4 minus. Okay? What's the problem? What problem do we have right down here? When you think about it, what happens with this? What type of carbocation is it? Is it primary, secondary, tertiary? It's a primary carbocation. What happens with primary carbocations? You get rearrangements. There's a hydrogen next door to it. This hydrogen takes its 2 electrons, and in reality, you think you're wanting to add a butyl group to your benzene ring, but instead, what you actually end up adding, because of the rearrangement, what you actually end up adding looks like this. So the hydrogen's now on the first carbon, and it's the second carbon, so carbocation. So when you add in your benzene ring, it's at 0 degrees. Instead of getting a butyl group hanging off of it, you would end up with this final product. Here, let me do it in a different color. You end up with this, and I'll do it in red. A benzene ring with that hanging off of it. Okay, which is not what you were wanting. You were wanting to add 4 carbons in. So the way to get around that is, since that's got a carbocation that can do rearrangements, is you first actually do an acylation reaction, and then you reduce that to turn it into an alkyl group. So I'll show you how to do that in a moment. So the way to get around the rearrangement of a carbocation, an example here that we were using was with butane, or a butyl group, is you first want to do an acylation, and then you do a second step where you reduce the carbonyl group. So this, you do a reduction, you reduce it to make it to the alkane. Now, there are 2 common methods. One's called the Clemmensen method, which uses what's a zinc-mercury amalgam in the presence of hydrochloric acid. There are pluses and minuses to that. You can do it at reasonable temperatures, but the minus is the fact that it uses mercury. The second one's called the Wolff-Kirschner reduction, and it uses hydrazine, which is explosive, but hydrazine along with either potassium or sodium hydroxide, but it does require high temperatures, and so you have to use something like a polyethylene glycol or something like that that boils at a really high temperature. So high temperature. Okay. And the reason why you want to do that, or do all of this, is because this step right here, the pseudo-carbocation, it can't do rearrangements. Okay, and so, because it's not really a carbocation, it's still held in place by the aluminum trichloride. And so, you can get around that, and it cannot do a rearrangement. Alright, so let's just work an example. Or actually, we can work with the example that we've been working on. So what we would do is we'd have our benzene with butanol chloride in the presence. So for step 1, you have to use something. You have to use your Friedel-Crafts catalyst at a relatively low temperature. I'm not a real stickler. You just don't want to heat it up too hot, and you're going to end up with the acyl group attached. 3, 4. Now, all you do is you just have to add, if you want to do the Clemenson, you would just add the zinc, mercury. Zinc is actually the one that does the reduction. The mercury is made in amalgam, sort of like the way that they used to do the silver mercury amalgams for the dental fillings, in the presence of hydrochloric acid. And you end up with your butyl benzene. Right? So hopefully this little tutorial here helps you. You will always want to do this anytime you have a possible rearrangement. And so I would say anytime that you have more than a couple of carbons in your whatever you're wanting, the R group that you're wanting to add to benzene, you want to do it this way. First, do the acylation, follow it by the reduction, because otherwise you will not get the product that you're wanting to get. And I'll see you in class.